question 10. So it's a cubic graph, so looking at this shape, crossing the x-axis properly at -1 and kissing the axis at -3 because this term is the squared one, so kissing at -3, so here, and then crossing the y-axis when x is 0, so that's 1 times 3 squared, which is 9, this shape. For part B, to be able to differentiate, we really need to just multiply this all out. So start off by multiplying x plus 3 all squared, giving us x squared plus 6x plus 9, then multiply by x plus 1 gives us this gathered to this. Then it's a straightforward differentiation where we reduce the power by multiply by the current power, reduce the power by 1, giving us what we needed to show. Now for part C, we're going to have to find an equation of a tangent, an equation of a straight line. We're going to use this big y minus y1 formula where we need a point and the gradient. Now to work out the point A, well, we know that x is -5. What is the y coordinate on the curve? Well, we substitute -5 into this, which I've done here, giving us the y coordinate of -16. So A is at -5 minus 16. Secondly, we need to know the gradient of the curve of the gradient of the curve, which is also the gradient of the tangent, when x is -5. So substituting -5 into the differential, remember the differential always allows you to work out a gradient at any point. So substituting -5 into this, we get the gradient being 20. So gradient 20, coordinate -5 minus 16, substituted into the big formula, simplifies down to y is 20x plus 84. Now for part D, we've got to work out the point B, which is parallel to point A. It's parallel, so it's got the same gradient. It's got the gradient of being 20. So on what two occasions is the gradient 20? We have 20 equaling the differential. And when we go and factorize that and solve it, we get two values. We get x being -5, which is obviously point A, but secondly we get x being a third, which is the x coordinate of B.